Hello, in this video we are going to see how dropping constants and lowered order terms affects the analysis of algorithms. So here we have the same algorithm we have been working with, and so let's do the analysis with our new point of view. This instruction takes a constant time, so it's not considered in our analysis. This instruction will also take constant time, but there's a function here, so we need to look at the function. So if we look at the function, we see constant time, not considered, or we have a loop here that depends on the input size. We are checking here how many elements the array has, so we are going to execute here this n+1 times, but as we do not care about constants, this is just n. This instruction inside the loop is executed n times, so this is n, and the return takes constant time, not considered. So if we sum only the terms that are dependent on the input size, this will be 2n, but constants, again, we get rid of them, so this is just n. So if we go back, we have n here. Remember that n is the number of rows of this matrix. And then we have a loop, and the loop is made of three parts. The first part is initializing the control variable I, takes constant time, not considered. Then we have this condition that we check in every iteration. We check whether I is lower than or equal to n, and we are going to check that condition n+2 times, but as constants are not important, this is just n. And the last thing that we do in the loop is updating the control variable, and this will happen n+1 times. Again, the constant is not important, this is n. So the whole loop will take 2n, but again, we are just interested in the rate of growth, so the 2 is dropped. We just finish with n. This instruction here is repeated n+1 times really, but the +1 is not important, n, and the last instruction takes a constant time, is not considered. So all in all, this will take some constant time plus some constant value multiplied by n, but since we drop the constants, this is just n. So the rate of growth of this algorithm is linear. The running time grows linearly with n. And this is why we just look at the loops usually when you analyze algorithms, because all the remaining instructions just add a constant time and you don't worry about the constants anymore, just about the rate of growth. So that's for now. Practice analyzing algorithms with this new approach.